talking about electron orbitals. To begin with, we're going to take a step back and look at valence electrons before we're trying to fill the orbitals up, okay? So let's take a look at the periodic table. You'll notice in the first period we have a maximum of 2 valence electrons. In the second period we have a maximum of 10. And in the third period we have a maximum of 18, correct? We have different electron orbitals, and they are going to be the s, p, d, and f orbitals. So s, p, d, and f. And you'll remember from the video that each of these orbitals has subshells and a different number of subshells. So the s orbital has 1 subshell, p orbital has 3 subshells, the d orbital has 5 subshells, and the f orbital has 7. And each of the subshells is able to hold a maximum of 2 electrons. So the s orbital can hold a maximum of 2 electrons, p orbital can hold 6, d orbital can hold 10, and the f orbital can hold 14. Okay? As we are filling up these orbitals, you can see that this right here is going to only have 1 s. There's only two electrons in the first period of the periodic table, so that's going to be our 1s orbital. The next one is going to be our 2s. It's going to be these two here, and then followed by the 2p. One does not like the first period does not have a p orbital, as you can see, because it only has the 2 electrons. This is going to be our p orbital right here. Okay, so then it goes 2p. The next one's going to be 3s, and then the next one's going to be 3p. Okay, we're going to go ahead and pause there so that we can look at the first three periods of the periodic table. So now we're going to show how these orbitals are filled up. So I'm going to need some volunteers from the class. We're going to do a little demonstration. I need 4 people to come on up. As you can see, the 1s is going to be the least excited state for those orbitals. So the 1s orbital will fill up first, and it's going to fill up in this manner. It's going to get both of its electrons. So this student who is sitting here on the left in the least excited state gets 2 treats. The next one is going to be the 2s. So the 2s is going to get the 2 electrons, right? And then followed by the 2p. So p has 3 subshells. It's going to be px, py, and pz. The electrons want to be as far away from each other as possible, because the like charges are going to repel each other. So they don't get to fill up all at once. So you're going to fill up the x, y, and z. Each get 1 before you start to double up. Like so. Does anybody have any questions so far? No? Okay. So after the 1s, the 2s, and the 2p have filled, we're going to go to the 3s. It's also going to get 2 electrons. And then we're going to go to the 3p. 3p is also going to have x, y, and z. And it's going to fill up in the same kind of manner. So top 3, bottom 3. Good deal. All right, guys. So does anybody have any questions on how this is working out so far? No? Okay, so we're going to do a couple of examples. So beryllium, as you can see, is going to be 2s in the 2s orbitals, right? So Be has 4 valence electrons. That's how you're going to start it. So how is it going to fill up first? It's going to fill up with its first orbital first, right? So 1s is going to have 2 electrons. So that's 2. And then it's going to go to 2s, and it's also going to have 2, correct? and then it doesn't have any more. So the next one we're gonna do is oxygen. So oxygen, you can see, has 8 valence electrons. So it's gonna do the same kind of deal. Start with 1s, and it's gonna have 2 electrons, and it's gonna go to 2s. It's gonna have 2 electrons. So now we're at 4, so then it's gonna go to 2p. I'm gonna have x, y, and z. I'm gonna do 1, 2, 3, and 4. Excellent. That's gonna be our lesson for today.